Welcome back, everyone. Today I'm going to show you how to make a solar system with particle effects. So to start off, I'm going to show you my completed one. It's the entire solar system with the asteroid belt, all the planets, except Pluto, and the Oerth shield, which is just a sort of spherical asteroid belt that's beyond the Kuiper belt. And there's a few little asteroids and such flying around occasionally in my particle effect as well. You can occasionally see them flitting by really fast. So to start off with, we're going to grab all my textures. The link to all the textures are in the description below, and I just copied them all. So there's my textures. Save them. After at this point, you would import them all. A few of these I didn't end up using, like the Saturn ring and the Uranus ring, just because my ringed FBX wasn't UV mapped very well, so they didn't really work out too well. So I just made it a base color instead of a texture. So anyways, so the first thing I started with is making all the materials. And the first one is going to be our master material. It's just going to be mercury, which I failed to spell. So we go in and we get a texture sample parameter as opposed to a texture sample just no parameter, so that we can change this in the instances, which are it's just a more efficient way of dealing with materials. You can just make a simple or a base material with some parameters, and the instances can just change those parameters and not actually mess with the graph. So this uses up less resources and less space, and it's just all around the best practice for making anything dealing with materials, to just have a base material with all the properties you want and then some parameters to modify the said properties. So our planet is just going to have a little glow effect plus the texture, because some planets glow a lot, like say Venus, because it gets a lot of sunlight, whereas something like Earth, not as much. Always make sure to save these, because they will disappear or break or something if you do not save and the game crashes, which it does quite often. So then you make material instance by right-clicking on the original material. I was sort of an idiot here and accidentally changed the parent to something else. So what I was actually supposed to do is go over to the parameters, and instead I accidentally changed the base material instead of the actual texture. That's fine, because you just need to set it back and everything will be fine. And I finally figured it out. There we go. Good job, Sanjus. You figured out how to use materials. But apparently not able to spell mercury. So anyways, the texture, your parameters will be under the parameter groups, and I didn't actually name my... Actually, I did. No, it's just called texture and then glow, so it's just the name of the actual node in the content browser. So repeat, create a material instance, earth.mat, and you change the texture to earth, whatever you named your imported earth map. Now the scalar, it's very bright, so you want to set the glow to lower, and for each parameter you have to actually click the check mark to actually get it to apply and not be the default. So since there's many planets, you're going to have to do that for each and every one of them. So next I go on to the sun, because the sun's going to be a little bit different than a normal planet. For one, it's going to have a lot of light coming out of it, and second off, the sun is looks very dynamic, or at least it looks good if you make it dynamic. And what I mean by dynamic is just have the surface sort of moving around like the actual surface of the sun, because the surface of the sun isn't really a surface per se. It's just a bunch of particles getting tossed about. So for the panner just moves it along the UVs, and obviously that's way too fast, so you can just tone down the speed, and that'll fix that. So what I do here is I take two texture samples, I make one have the panner and one not, and if I combine them, it gives a sort of effect of the surface moving, but the layer under it isn't, which looks cool. I wouldn't say it's scientifically accurate representation of the sun, but it is something. And obviously, you want to plug in the mist because the sun is a very bright thing. You could probably tone it up quite a bit too, and it'd still be fine. Alright, we got our strange glowing sun. So, onto the meshes. So, due to the nature of the particles, you can't just sort of switch out the static mesh. You just end up having to make a new static mesh for each mesh particle in the particle system. That'll make sense here in a bit. So you're just going to want an editor sphere or any other type of sphere, copy it over to your meshes. Once I get to that, of course. And this is the solid color I was talking about for Saturn's rings, since its UV maps kind of suck. And I just gave it a little light tan color. Again, saving is important. Since I've already shown you how to actually make each of these, I'm just going to copy them over. I'm probably not going to use all these just because it's kind of repetitive and I don't really want to be condescending by doing the same thing over and over again. I just have to do it a couple times, and you can go back in the video if you really don't understand it. So now I grab a editor sphere static mesh, which is just a sphere. I always go to the editor spheres for my spheres because there's a lot of different spheres in the dev kit, and some of them won't work. Like some of them have holes in the tops and bottoms that you don't notice until you've done this 8 times. Then you realize it looks terrible because there's a giant hole in your planet. So again, you have to copy and paste each of the meshes and just give it the new material. I wish there was a better way to do this, and actually if someone can find me a better way to do this, I'll happily add a correction in the description of the video or something. So again, I've shown you how to add a material to a static mesh, so I'm just going to copy all of mine over. And now, the part you've all been waiting for, making the actual particle system. All this stuff has just been prepped to do this efficiently. So first off, we set the amount of spawns per second to 0, and then we just make one spawn when the particle system starts. Then we set the lifetime to 0, which actually means infinity, so it'll just never die. And we set the duration to 0, so that's the actual particle system as opposed to the actual particle. So like the particle system is all the particles in the system, whereas the lifetime is just for each individual particle. So anyways, we're going to make this mesh data and set it to our sun. Also, before I also set the loops to 1, so the particle system just goes one time and it's just there forever. You might want to have it occasionally spawning new particles, like, I don't know, every 60 seconds or something. If, say, if you want to actually use this in a mod or something, because sometimes the server freaks out and the particle effect does its thing, but the particle disappears. And then you would have an issue where no one can see it anymore because particle effect glitched out like this. I accidentally clicked the wrong material, and some materials do not work with mesh particles. You have to actually set it in the material. And if you don't, well, you get this cascade of errors like you saw right there. So, and then we repeat. So this one's going to be Mercury, which is the closest planet to the sun. So there's a very important module in particles in terms of this sort of stuff, and it's called the orbit module. So I'm going to look over at my original one to show you. So the original one looks like this, and as you can see, all my different planets have orbits on them except the sun. And the orbit module is just an easy way to make particles indefinitely orbit an object. And you have a lot of control over what you can do. Like, you can make overlapping rings and such, and all kinds of other cool effects. But for now, we're just going to have planets. So it's over on orbit and orbit. So the offset is how much it's offset from the center of the orbit system. And of course, the size needs to be adjusted because the sun was way too small compared to Mercury at first. So it's kind of going crazy right now because the rotation is set on different axes besides the single one we want, which is the z-axis, I think, in this case. And I suppose if you wanted, you could offset it a little bit so that it resembles a real orbit in which it sort of goes, it's not a complete circle, but I'm not really scientifically accurate with this, though you can be if you want. You just have to do a bit more work to get it to be scientifically accurate. So the second important thing is the rotation rate. So if you just randomly plug in values into this, you're going to get this situation where the planet is rolling like a ball. And planets don't really roll like a ball. They spin on an axis in the middle. They don't just sort of fall over. So in this case, what you want to do is set the rotation to be on the z-axis so that it rotates on the z-axis only and doesn't roll around. It just spins around a single axis. So now we duplicate, and this one's going to be Venus, I believe. So, of course, you're going to want to increase the orbit offset for each one so it's further away from the center and each other. And there we go. Actually, so normally you set the required module, and that's the actual material it uses, but in this case, since it uses mesh data, you have to go to the mesh data module and set the static mesh in there, because the actual material in the required module isn't actually used in a mesh data particle. So here we go. Once I change it, it actually changes for real this time. Wow, look at it go. So another thing, you're going to want to have different rates of rotation and such on these on each planet, so that they're not all like locked like a giant rod of planets sticking out. They want to be on different. They want to be on a different offset, but they also want to be moving at different rates, so it looks more interesting. And of course, I've made the particle system too big, so you just right-click the bounds up there and set fixed bounds, and that'll recalculate because you made the particle system bigger. So it just needs to recalculate to know that you're actually near the particle system, and that shouldn't de-render it when you look away. So I think a more in-depth explanation would be the bounds are just the area that you're in that you see the particle. So if the bounds are too small and you look away and the particle whizzes in front of you, it won't actually render because you're not in the bounds and you're looking away. But if you are in the bounds and you're looking away, that particle will render, if that makes any sense. Again, if you want to work out all the ratios and make it completely scientifically accurate, go ahead, but I don't really have time for that in this video. So now we are going to work on an asteroid belt, and that's a bit different from what we've been currently doing. I'm just going to use the Mars mesh for now because it sort of looks like an asteroid. If I were you, I'd go for an actual asteroid mesh with an asteroid map on it, but I didn't really have something like that available at the time. Well, actually, before we do the asteroid, what we're going to want to do is we're going to do a flare coming out of the sun, and we're going to just make a new particle emitter and set it to the imp flare. So if you saw, the screen alignment setting it to rectangle just lets square-ish particles become rectangular instead of just becoming, like, think in Photoshop. It's like square mode just makes the selection square no matter what. So if you set the width to 100, the height will scale accordingly. Rectangle just disables that, so you can have really long particles like this. There we go. So I set a random rotation, so it randomly spits out of the sun. I couldn't really figure out how to get it to spit out sort of like a mesh, and here you set the color to yellowish and then turns a bit more reddish as the lifetime of each of those little flares goes on. So next up, there's kind of a bit too many flares, and the size could be a bit more variable. If you set the min and max different in particle systems, what will happen is instead it'll just choose between that range randomly to create a sort of diversity in your particle system that you couldn't really get if you wanted to. You couldn't get otherwise, because it wouldn't really be fun to make 20 different particle module things just for each variation. So anyways, that looks alright. So the next thing is I make another particle emitter and make its velocity in random directions from the center of the sun. And what will this be is just like little embers coming out of the sun. Again, not scientifically accurate, please don't kill me. So they'll be variable size, and they'll just sort of spit out from the sun constantly. And of course, they need to be orangish because the sun is orangish, or our sun is at least. There we go. It's spitting out particles when you get close, and we have the makings of a little inner solar system. Now, we're going to want to duplicate our Mars that we made a little bit ago, and this is the one that I mistook for starting the asteroids. Now we're actually going to start the asteroids. So it's going to be a bit of a ways out from our current planets. And I kind of had to fiddle around with this a little bit. But anyways, in order to get multiple... Actually, I'm going to show a few different things you can do here. So as you can see, I made it have an offset randomly on the current axis that we're using, and that'll just make them randomly spawn in that ring sort of between those two. So what was it? 900 is at the starting point, and 1400 is the furthest distant. So anyways, if I change the x, it sort of becomes... It doesn't do what you would expect. It doesn't fill up the ring. It actually just sort of juts out instead. And the same... Actually, no. If you mess with the z, what's going to happen is it's going to go up and down instead. So still not exactly what you were going for if you wanted to fill out the ring, the orbit path with asteroids. Well, that's all your offsets. So, and that should be an offset, right? Well, let's go look at my example. So we go over to our asteroids that I made here. And as you can see, I have it going up and down a little bit, and a little bit of change of the y offset, so it's a thicker ring instead of just a line that goes in a circle around the sun. So you can't really... There doesn't seem to be anything that'll help here, right? That's pretty much what we already have, so let's go back in a second. What are we doing different is the question, right? Obviously, it's not the mirror flags. Those are the same as over in ours. So what could it be? So let's try out a few other things. So again, this will just make it go up and down. Mirrors are the same. And if you notice, it sort of has a kind of weird offset. Like it's sort of tilted. I think that's just because of the rotation. But I couldn't really... I'm not really an expert, so I couldn't tell you. But yeah, it does sort of look odd. Like it's shifted slightly. But anyways, that's not going to do anything. There's a few check marks that I'm not sure what they actually do, like those. So now we have a giant ball of Mars. Not exactly what we were going for. Though I feel like that could be useful somehow. Now it's a cube of Mars. So that's all three of the different offsets at once. As you can see, if you made it sort of curved, I think you could get a sort of like... You could sort of simulate a galaxy with its spiral arms like that, but not what we're doing. We're doing a solar system, not a galaxy. And scale, add, and link are... They're basically used to let you nest orbits within each other, but that gets complicated really fast, so I won't be able to explain that in this video. So if you wanted to know the real difference, it's because of the rotation. So the rotation, it's different from the rate that it's rotating. The rotation is sort of how much it's around. So like there's 360 degrees in an orbit, right? The rotation amount is how much of that is being used. So if you do 0.9, it's going to use up 90% of those 360 degrees. So 0 will do that, and 1 is what we were going for. So what happens if we do 5? As you can see, it uses 180 degrees of our 360. If I put, say, 9, it has a little gap. So that could be useful if you're... I couldn't really say what it could actually be useful for, but I think it's important to note. So anyways, messing with the size, you're going to want to have some somewhat normal proportions, because as you can see there, if I set the minimum too low, you get sort of paper asteroids, and that's not really what you want. So these are asteroids. They're different sizes and shapes for the most part. Personally, if you wanted to make this really cool, you could do, say, get 3 different sort of asteroid meshes and mix them together in one asteroid belt, then have actual asteroid textures on them, but we won't get that detailed. There's a lot of different things you could do here too. Like if you mess with the rotation and bring it up a bit, it'll actually sort of make it conical instead of just a flat orbit, which that's cool and all. And if I set the Y higher now, you're going to get a really interesting effect here in a second. So now you've got like these weird overlapping rings, like a spring toy that goes down. There's a lot. This is one of those weird things that I've done, and I probably wouldn't be able to reproduce reliably when it comes to particle systems, but it's there. If you want to have some real fun, I'd try nesting orbits within each other and such, and see what you could do. So the last part is the little comets that fly around. I could do the whole solar system, like from the beginning, the one that I showed at the beginning, but it'd basically be, we'd just do the same thing with Saturn and Jupiter and Pluto and Neptune and all that, as we did with the first few planets, and then we'll make the Kuiper belt, and then we're going to make the Earth shield, and it'd just be too repetitive, because we'd be doing the same thing. So anyways, I need to start in a sort of slice of here instead of everywhere around it, because if you set the Z max to 1,000 and the minimum to 1,000, what's going to happen is half of your comets aren't even going to spawn anywhere near your solar system. You want it to be, because the solar system that I'm making right here is largely flat, so you want to have the Z-axis not that high. Also, the lifetime, you're going to want it to be fairly high, just so comets aren't just randomly disappearing. They'll by the time the velocity takes them out, that's when they'll disappear, when they're outside, since their lifetime's so long. And that's good. So their size is a bit much. You can honestly play with this a little bit, just because on one hand, you want to make them visible. On the other, you don't want comets going through your solar system that are half the size of a planet or an asteroid or something. That'd be terrifying. What you can do to make them more visible is to crank up that color value, because the emissive can be, I forgot the exact name for it, but basically the engine's not going to stop you from overvaluing things. And I had to set the fixed bounds again just because my particle system got too big. So now let's look at our creation. It's not as grand as my first one, but with a little bit of work and some time, you could definitely turn this into the first one without learning anything new. So there we go.